My name is Sven König. I'm one of the engineer here in the Lango lab, and I'm responsible for the IC test equipment here in the Lango company. And I want to give you today this short presentation or this introduction here in this calibration system or the calibration of the P200 and P202 and P302. Yes, we have here two cameras, so one in front of me and one here above, so that you can see all the details when I set up here the equipment. Then we will switch also between my monitor or my laptop so that we can go through the calibration instruction. And also we can switch to the oscilloscope so that you can see what setup you should do in the oscilloscope. Okay, good. Then let's start here with calibration instructions. So I hope you can see now my screen and also my mouse. This is the calibration instruction. So we have here the content and some general information. I think that's, So here the introduction, the calibration interval is 2 years for these probes. Then we go over to the devices and accessories, what you need here to do this calibration. As Christian already said, if you have some questions, if you don't understand anything, then please interrupt me and we can go more in detail here for the things. What we need here for the test or for the calibration, at first we need the ground plane, the GND 25. This is a part of the ICE1. I think you all also have this system. So then in the GND, we have here an opening of 100 by 100 millimeter. Here for the calibration, we also need a ground adapter. This ground adapter here has the opening of 32.9 by 32.9 millimeter. You have to place this adapter here into the ground plane. There are some magnetics under it so that it's fixed here inside. Okay, then for the measurement here, we need the calibration system, the RVM 01. This is a volt measuring system. It's only a voltage divider where you have on one side here the contact for the probe, and on the other side here you can connect a cable, and this cable then is connected to the oscilloscope. This voltage divider here has a dividing factor of 100, so it's 40 dB. So that you also can measure both probes with this system, the 202, which has a maximum voltage of 40 volt, and also the 302, which has a maximum voltage of 500 volt. With the dividing factor of 100, you have here at the output maximum 5 volt, which should be no problem for the input of the oscilloscope. So that's the reason that's good that you don't need external attenuator or something else. So This voltage divider you can fit here in this ground adapter, place it there, and then on the bottom side here, there is a fixture and screw where you can fix it inside this ground adapter. Okay, then we need an RF cable here with a length of 1 meter, and this cable has on one side a SMB connector. This is for the connection to the voltage divider, and on the other side here you need the connection to the oscilloscope. There it depends what kind of connection or connector you have on your oscilloscope. So then connect the SMB to the voltage divider, and the other end here I connect to my oscilloscope. Here I use channel 1, and there's a BNC connector here at my oscilloscope, so I can directly connect it. So now that's our calibration setup, and then I need, of course, the probe and the complete P200 and P300 system. I start here with the high voltage supply with the power station BPS 202. Here at the station you have the connection to the probe. It's on one side, and on the other side you have the USB connector to connect it with a computer or with a laptop, and also the power supply. The power supply, or this station here, comes with a 12-volt power supply. This you can connect it here, and also the USB cable to connect it to the laptop, which is now connected to my laptop. Then we have to connect here the probe to the power station. There we need this cable, which comes with the equipment. There, both ends are the same, so you have to connect one to the power station, and then you use here the probe. I start with the 202 probe, where you connect the other side of the cable. So if the power station is powered, then you will see when you connect the probe that the screen LED here is on. So now you can place the probe on the ground plane. So I think now we have all the equipment we need for the calibration. So now we can start, or we can go over here to the calibration instruction. So I think all the things we have here: the oscilloscope, the measuring cable, here the A, SMB, coaxial cable, then the oscilloscope. I think we come to the next page here. Yeah, these are the measuring conditions: temperature, humidity, and yeah, this is the description of this voltage divider, or voltage divider. That's what's already what I already described to you. Here's the SMB 50 ohm output. That's very important. We have the contact here. It's a divider of 2.5 kilo ohm to 50 ohm. Yes, and here on the top side, there is the contact, the measuring contact for the probe. So you have to insert it in the GNDA 02. This is this ground adapter. So we already have done this. Yes, here we have the block diagram. That's the BPS 202, the probe, one of these probes, which is connected to the voltage divider, to the measuring system. Both are located on the ground plane and then the ground adapter, and the voltage divider is connected to the oscilloscope. Here you can see the calibration setup in the picture. So now we come to the oscilloscope, to the settings of the oscilloscope. For this we have to go over here to my oscilloscope screen. I used here a LaCroix oscilloscope with measuring bandwidth of 1 gigahertz. And yeah, your settings here, I used for the settings channel 1. You see here channel 1 has a coupling of 50 ohm DC, full bandwidth. And here I set the attenuation to factor 100. That's the attenuation of our voltage divider. So the voltage you can see now on the oscilloscope is exact the voltage of the probe. Yeah, so that's the settings for the channel here. What else do we need? I can close this here. Yeah, then we need the horizontal scaling. Horizontal scaling I set here to 5 nanoseconds per division. That's good enough to see the complete pulse. Yeah, then I think all the things, yeah, the trigger setup here. So you have to place the trigger here. So and for the trigger edge, for the positive voltage, you have to set the trigger to the rising edge, that you trigger on the rising edge, and of course for the negative pulses, you have to set it to the falling edge. The trigger level should be located somewhere in the middle. So when you want to measure a pulse with one, with 1 volt, then you have to set the trigger to the middle level of 500 millivolts. So what we also need here for the measurements or the pulse measurements, you can see here on the measuring setup, I insert here 2 measurements. One measurement is the maximum value of the measured signal, and the other one is the minimum. These 2 values are important for our measurement here, for our calibration, and you can see these 2 measurements here, this measuring list. Measurement 1 is the maximum, measurement 2 is the minimum. So yeah, for us interesting is not the actual value, for us interesting is the mean value of the measured value. So, and for the mean value here, we need a number of 10 measurements, so that, or minimum 10 measurements for our mean value. So before I start the measurement, I have to clear my sweeps here, and then you see here that the number of the measurements is increasing. So you see after a short period here we have 200, 300 measured values, so that's definitely enough for our mean value. Okay, I think these setups here of the oscilloscope should be enough. So then we go over to the settings of our power station and the settings of the probe. For controlling the BPS power station and the probe, you need the software. You need the software BPS 202 client. You can see now here on my laptop, on my screen. I will power off the BPS again, so that you can see that here the BPS is not connected. And after I switch on the power supply again, then after a short time, you see BPS is connected, and also the probe here. We started with the probe P202. Yeah, is also connected. Here on help, you can see the hardware information in this software. On the hardware information, you see the BPS type. It's BPS 202, manufacturer, hardware version, firmware version, serial number, and also the same of the probe. The probe, which kind of probe you connected here, and hardware version, firmware, and also the serial number. Here on the probe, there's a special table on this probe where the calibration values are saved on this probe. So yeah, good. Close this again. Now here I will explain the settings of the software. Here in the mode, you can change between pulse mode and burst mode. For us, for our calibration, we need pulse mode, and the frequency of the pulses here is, for our test, it is 1 kilohertz. So we have the minimum frequency you can set here is below 1 hertz, and you go up to 10 kilohertz. That's the maximum repetition rate here of the pulses. Then the next is the pulse level. Here we have two ranges. We have a low voltage range and high voltage range. For the calibration, of course, you have to test both ranges. We start now with the low voltage range. This low voltage range started at 400 millivolt and goes up to 7.5 volt. And in the high voltage range, it takes some time to change it. So here we start from 8 volt to the maximum level of 40 volt. Let's start with the low voltage range. So, and here with the slider or with these buttons here, you can change the value of the pulse. Pulse polarity, positive, negative. That's something you also have to change during this testing. We started with the positive polarity. Yeah, and counter timer, these are all disabled because we don't need here for this calibration. Also external trigger is not, we don't need here. Yeah, one special thing here is now, before you start with the calibration or before you start to contact the probe, you have to switch on the probe tip contact detection. This you will find here in the menu under probe and then probe tip contact detection. So, this is Yeah, this is a detection internally in the probe, so that you can see when you are contact to a IC pin, or here we needed to find the contact of the voltage divider. So now you can place the probe, or you see that the LED here on the probe is green, and when you contact the voltage divider, then you see the LED switch from green to blue light. And blue light means you are connected to the voltage divider, or when you test the IC pins, then you can see that you are connected to the IC pin. If I go a little bit next to this contact, then you see it's green. So it means the probe is running, of course, but you are not connected to any measuring device, or to this measuring device. So now I'm contacted here. And now we are ready for our first test. I think I can start here with, I can start my probe. So you have here two buttons. Single pulse means that you could wait only one pulse. You have here to start the pulsing. And now the probe is creating the pulses with a frequency, with a pulse repetition rate of 1 kilohertz. Here you can see on the probe that the LED is blinking. So now let's see the oscilloscope picture. Here on the oscilloscope, you have to set the, you have to change the vertical settings so that you have minimum 70% of the pulse in the screen of the, or in the measuring range of the oscilloscope. So, and then after that I start I clear my sweeps, my measuring sweeps, and now you can see here that's the actual measured value, and that's the mean value here. And I set in the software 1 volt pulse level, positive pulse level, and now you can see here it's 1.02 volt. So that's definitely good enough. So now you have to go over to my laptop, and here I prepared a list. I prepared the Excel sheet where you see all the voltage levels for the positive voltage range and also for the negative voltage range. And here I placed in one column the set value, and on the other side, the next to here, the value is the measured value. So now I measured at 1 volt, I set it 1 volt in my software, and now I measured 1.02 volts. And then you can see it's a deviation here of 2%. So, and that's okay, because when we do this measurement here, we allow a deviation of plus minus 5% of the measured values to the set values. So if you set this value, then you go back to the software, and then you go to the next voltage level, 1.5 volt. Then let's go over to the oscilloscope. You see now I'm out of the measured range here, so I have to increase the level here. So start the measurement again, and now we see we have 1.57 volts. And then you have to 1.57. And so that's very near to 5%. But here in this low voltage range, sometimes you only have a difference of a few millivolts here, and this creates some deviation. But this is definitely okay here. Good. And yeah, that you can do here for the complete low voltage range. Then you have to stop again. Then you switch to the high voltage range. In the high voltage range, you saw that at 8 volt. Stop pulsing. So, and change in the oscilloscope. The settings so that you can see the complete pulse here in the oscilloscope. Also the trigger level. Should set it here to the half of the value. So clear the sweeps, and here you can see now the measurement 8.18 volt. And then you fill it also in the table. So, and that you can do for all of these voltage levels. You see there are a lot of, I think we have here around about 50 voltage levels, and for the positive, and then after that, stop this pulsing again, change to negative polarity, and start. And then when you started the negative values, you have, of course, you have to change here the trigger. The trigger edge is here. Change to negative, and you also have to put level. And now you can see again the pulse. Clear the sweep so that we see the measurements now here, and now we have here a level of 8.3 volts. Yeah, and then you can go on also for all of these negative pulse levels to fill out this table and to complete the calibration. And if everything is completed, then you should see that all the deviation values here should be lower than 5%, plus minus 5%. Good. So stop. Yeah, I think that's all. Say goodbye and have a nice rest of the day.